welcome everyone that is attending now. Well, first of all, I'd like to talk about GAIA, this global network that is this organization. GAIA is a global network of grassroots and national organizations from 92 countries around the world who are working together on waste and justice. These these are the regions where GAIA is now working. You can see in US, Canada region, Latin America, Europe, Africa, and Asia Pacific. Thanks. Hello, everyone who is writing in the chat. This is the program. We have in the first part, the presentation, the GAIA's key conclusions on our document, our Q&R document. We have 15 minutes that Lynn will be our speaking for that. Then we have 5 minutes to FARN and 5 minutes to Earthworks. These are our invited organizations. They will share with us their perspective on this document. And then we have the last 10 minutes to share the Q&A questions that you are going to chat in our chat. So these are our team and our speakers today. I mentioned Lynn de Brucker. She's the Global Batteries Lead in GAIA. Sheila Davis, the EV Battery Waste Coordinator from GAIA US and Canada. Who is speaking, I'm Janina from Latin America, Just Transition and EV Battery. And our invitation, Pia Marchegiani. She's the Environmental Policy Director and Deputy Director at Fundación Ambiente y Recursos Naturales. And Raquel Domínguez, Circular Economy Policy Advocate from Earthworks. So this is my final word. Now I invite Lynn to present this document. Thank you.
Thank you so much, Janina. Also, I love that it is a female-dominated webinar on a highly technical subject. So welcome, everybody. I'm happy to have this opportunity to briefly share with you some of our key findings in our analysis of EV battery recycling. First, I'll start with some basic concepts. Then I'll present the environmental justice criteria by which we assess recycling. And then I'll end with some recommendations. So why does EV battery recycling matter? Because shifting the transport sector, we all know, from fossil fuel dependence to electrification is a necessary and crucial step to reduce emissions. At the same time, battery manufacturing is today exceeding demand, leading to overproduction that many entities have already taken note of. And recycling is seen and spoken about as a way to reduce mineral demand. So we'd like to look at that more closely. So what is EV battery recycling? Well, it's dynamic and it's not easy to understand what's involved, but we've tried to simplify it. So after a battery is removed from a vehicle, most of the information available today is speculation. It is informed speculation based on, the use of manufacturing scrap, which is a homogeneous and predictable feedstock, or it's speculation based on what happens to consumer electronics. But because most electric vehicle batteries are still in the vehicles today and they won't actually reach their end of life until 2030, we don't yet know what any operation at scale will look like. We also don't have information today on how many batteries are reused or repurposed when they are removed from a vehicle at 80% capacity. So as we've been looking at the many different proposed processes for recycling electric vehicle batteries, they all use inconsistent terminology and they combine different technical processes and different arrangements of steps We've presented them here as step one is pretreatment. Then that intermediate product can go to metal extraction. And then step three is where again, the intermediate product that's produced will be finalized for end product preparation, which is that cathode and anode material that can be used in another new product battery, right? And so I'll go into a bit of detail on the next slide into what is steps one and two. The newest pathway that we're hearing a lot about, hydrometallurgy, is the broad label that's given to it. That requires pretreatment. So the battery is discharged, and then it is, through mechanical disassembly, wet and dry shredding and crushing, dissolution with solvents, and more thermal treatments such as pyrolysis or calcination. At the end of step one, and I know this, I apologize, this graphic is a bit small on the slide, but the black blob in the middle is black mass. And you might have heard of black mass, but that is a product made up of an intermediate product that has a large quantity of graphite in it, and it contains materials that are classified as hazardous waste under international conventions such as the Basel Convention. However, national regulation may or may not, right, classify black mass as hazardous to ease import and export restrictions. And so the EU, for instance, has classified black mass as hazardous. In step two, for batteries that have undergone this pretreatment to produce black mass, that black mass then in step two undergoes acid leaching. And that's what's the hydrometallurgy step here, where massive quantities of toxic acids and solvents are applied to black mass in order to produce another intermediate product called leachate. There is an alternative pathway that skips pretreatment. And in that step, the battery is again obviously discharged, and then it goes directly, no black mass, into smelting. Though there are options too where black mass can go through a smelting process. As I said, there is no single one path. There are a multiplicity of pathways. But for those batteries that directly go into smelting, that is an energy intensive process producing high greenhouse gas emissions. And so that resulting alloy from the smelting process still, again, goes through hydrometallurgy. Same style of process of use of acids in order to then recover the process that, next intermediate product that still needs to go through then step three on the next slide of producing the actual precursor active cathode and anode materials. So that was a lot, and and a lot of the terms that I've used, we don't necessarily have common agreed upon definitions. And so in the glossary in the Q&A document at the end, we've taken care to write a glossary of what do we mean when we use pyrometallurgy and hydrometallurgy and smelting and incineration, so that we can have a shared vocabulary and understand that content. And one clarification that is important for this webinar is that when I'm using the word pyrometallurgy and when GAIA uses it, we use it as an umbrella term to describe the full range of high heat thermal treatments that are possible, including incineration, smelting, calcination, and pyrolysis. So it is an umbrella term. It's not just limited to smelting, which is a common misunderstanding that we're seeing. So where does that leave us? How do we look at recycling? For GAIA, recycling is appropriate when all other uses of a material, here the battery, have been exhausted. So on the next slide, we see that an effective recycling process will safely treat and convert all components to reusable material in the same or equivalent industrial uses. And what do we mean when we say safely treat? It means that we avoid the use of intense hazardous chemicals. It means that we avoid high heat thermal treatments, especially smelting and some of the more nefarious high heat thermal treatments that we don't understand enough right now about what industry is using. We have many questions that need answers. And then we also mean For us, a safe treatment is one that avoids toxic air emissions and hazardous waste byproducts. So in order to better, analyze EV battery recycling, we've defined 5 sets of criteria. Number 1, maximizing recovery of all materials and reducing the energy intensity of the process. Number 2, minimizing air, water, and toxicity hazards in the process. Mandatory manufacturer responsibility, easier said than done, right? Benefit sharing for workers and communities, and then strong safeguards on waste exports. And I'll break these down now in the next 2 slides. For recovery of materials and toxicity, we assess that with the following criteria. What is the fate of all materials, the mass balance that enter the recycling stream? What is the total carbon footprint and energy use, not just at one facility doing one step of the process, but the carbon footprint from collection to transport and logistics and the recycling steps, all of the recycling steps, and the embedded emissions of the acids and chemicals used. So for very large quantities that are needed in order to do the hydrometallurgical processing. For air, water, and toxicity hazards, we assess using the following criteria. What are the toxicity hazards of air pollutant emissions to frontline communities? So you see here a photo from Endicott, New York in the United States, where a community protested a recycling facility for its harmful PFAS or forever chemical and other emissions. Another criteria is what are the water effluents and contamination risks to frontline communities? The other picture here is of an EcoPro facility in Korea that released heavy metal in its wastewater and killed the fish in the nearby fish farm. And the next criteria is then what is the water use intensity and the wastewater burden? And here again, we've been following a major facility in Nevada in the United States that lacks transparency and hazard assessment about their toxic air emissions and the wastewater release of their facility. And then the next 3 categories, we have mandatory extended producer responsibility, looking at also does that EPR policy include eco-modulation criteria, rewarding design choices for material conservation and assessing penalties for designs and software locks. I've seen contradictory messages that I have both 5 minutes left and that I should slow down. So I will try to summarize then on benefit sharing, looking at really what are the benefits by which process for our benefits shared with workers and communities in the value chain. And then for waste trade, as I said before, the systems and safeguards on exports of spent batteries and black mass, especially to avoid waste colonialism. And here you see the picture of, this is an e-waste dump site with lead acid batteries in Ghana from a GAIA member organization. In the next final section of the presentation, I'll talk about 3 big barriers that we see to scaling up some of the new battery recycling processes. These are maturing technologies. They require further optimization. We have economic barriers. Recovery of cobalt and nickel can be profitable, but it remains cheaper to buy newly mined lithium, graphite, and manganese than it is to recycle it. Obviously, this all depends on market conditions, but certainly also with an increased market share of lithium iron phosphate or LFP batteries that do not have cobalt or nickel to pay for the recycling cost. This is a major economic barrier. Another barrier is that the recycling feedstock will be highly variable and unpredictable. So many aged batteries with different configurations and means of disassembly and chemical composition, and we don't have regulation mandating strict labeling that can facilitate the sorting needed. And then these newer hydrometallurgical pathways are very sensitive to impurities, which means that the quantity of acids and energy required to process this very heterogeneous feedstock will likely be higher than what is predicted today. Additional challenges are the fire and safety risks, the narrow performance goals of current standards, looking mostly at recovery of critical minerals. Workers might be excluded from the recycling boom, especially informal workers, and then the high costs of collection and transportation logistics. So will EV battery recycling reduce primary mining? In order for it to do so, the process has to produce recyclates, the end product, right, of battery grade material that can compete with primary mineral extraction. And yes, certain reports claim high recovery rates that they assume will reduce mineral demand, but the analyses appear based on undisclosed or unavailable industry data and on assumptions that the many challenges I listed above will be successfully resolved. So our main ask at the moment is to release data and to get access to data that will allow verification of these claims. Because we want to make sure that the challenges to scaling up are overcome in a way that maintains the high recovery rates, that produces cost-competitive battery-grade recyclate, and avoids causing significant harm to workers, communities, and ecosystems. So I'll end with a few policy recommendations. And I know I've been saying a lot. It matters how we define recycling. Incineration and smelting are not recycling. In policies that are emerging at state level in the US and elsewhere in the world, we have to make sure that these processes that destroy materials, that they are not passed as recycling. We must require industry to disclose data to avoid planned obsolescence and e-waste, which is a current risk that we're seeing. This includes automakers making vehicle battery data accessible and free from proprietary software locks. It also calls for battery recyclers to make data available on material recovery rates, their energy and water use, and their air and water emissions. And again on EPR, and then scaled up funding for battery design to change the very design of the batteries to allow repurposing and safe recycling. Again, this has been a lot. So if there's only two things that you take away from the many things that I've said, it's number one, please look at battery recycling with a more critical lens. Get access to the data and information and avoid falling into a trap of believing what the beautiful words that industry speaks. We know from the recycling of plastics that industry can make false claims and market the promise of new pilot technologies, but then those technologies fail to mature. They do not deliver technically and economically at commercial scale. The next takeaway, to reduce mineral demand, there are other, more impactful, more effective pathways while industry is sorting out, right, how to improve recycling and make it economic and reduce. And while we're putting pressure to make that process safer and less toxic, let's look higher up on the zero waste hierarchy. We are not alone as GAIA to call for measures that reduce the material footprint of batteries, smaller vehicles, improving energy efficiency standards, and incentivizing reuse and repurposing of batteries before recycling. And this requires fair and equitable access to battery data is really, really critical as part of this, including other design measures. So thank you. I'm sorry it was a lot and a bit long, and I look forward to hearing from Pia and Raquel next.
Thank you, Lynn. I will remember for everyone that this webinar is being recorded. So after today, you can search the GAIA YouTube channel and can find this webinar. Now, the Pia is going to share her perspective. Pia from Fundación Ambiente y Recursos Naturales. She will talk in Spanish. So everyone who can change the simultaneous icon translation, you can switch there. So Pia, go ahead. Thank
Muchas
you.
gracias.
Al
¿Se
inglés.
escucha bien ahí?
Thank you very much. Can you hear me well?
Sí, perfecto. Gracias.
Buenísimo. Bueno, antes que nada, muchas gracias
First
a
of
GAIA
all,
por
thank you
este
very much.
espacio, por
Thank you,
poder estar
GAIA,
acá, comentando
for giving me
este
the
excelente
opportunity to be
informe.
here.
Creo que
Thank you for
aporta
sharing this
mucho,
excellent
a
report.
pensar en
I
los
think it
debates
really
de la transición
contributes a lot to
energética
help us to think
y
about these
aunar en
energy transition
particular a
debates,
problematizar una
and
mirada que
especially
apuesta por un mero
to
recambio
show
tecnológico
the
sin una mirada
difficulties
más integral y
that are
holística
involved in
porque la crisis
this
planetaria
proposed
involucra
energy
muchos más aspectos que
transition,
las emisiones,
because
¿no?
it's
Que es una crisis
actually
de
much more
biodiversidad y
complex
de
than we think. It's much
contaminación.
more
Y
diverse,
este
this whole
informe
issue
también
of
ayuda a hacer
pollution. And this
preguntas
report
sobre
also helps us
las
to make
diferentes asimetrías y
questions
las discusiones
about
de
the
la
different
complejidad que atraviesan todos estos problemas.
asymmetries and the
En primer
different
lugar, quería
issues
felicitar
that
la
affect
muy
lots of
muy
different
bueno el
related
informe,
topics. So
intensa
thank you very much for your
información y
report.
valiosa
It really
información
brings
técnica
together
que
a lot of
Lynn trató
information
recién
in a
de volver a explicar.
succinct
Y
format.
es un formato sencillo, aunque
And it's a
complejo,
very
pero que
simple
para no
format, although
expertos
it's
les permite entender
complex,
bien
but it
los
allows
procesos en
non-experts
juego, ¿no?
to understand
Y
the
lo que voy a
processes and
decir
what's
en
at stake.
pocos minutos tiene que ver con algunos aspectos que me
So
llamaron la
I would like to
atención.
share some
Como organización que
aspects that
trabaja
caught
en
my
temas
attention.
ambientales,
We
vemos
work with
lo que
environmental
Lynn decía al
issues,
final, que como muy
and as Lean
llamativo
said
la
at the
cantidad de
end,
aspectos de vacíos
it's
de
very
información que hay.
surprising
No hay
how many information
data
gaps
disponible,
are
no está
out there. There's
generada o
data
está
that's
bajo
not
circuito
available,
industrial. Esto lo
that
vemos en
hasn't
un montón de
been
conflictos ambientales que
created,
puedan
or that
tener.
is not
Y
available.
también la idea de que las afirmaciones
And
y
then there's also
supuestos
this
no pueden ser
idea that these
corroborados. Esto lo que
claims
decía Lynn al
cannot be
final, y me
corroborated. This
parece
is what Lean was
un
saying at the
aspecto
end.
central para también
And I think
llamar
this is
a la
key,
trazabilidad de los datos y la mención
because
de
we have
las
to
fuentes o la
call for the
contribución de los fondos de
traceability of
investigación
data, and we have
aplicados, ¿no?
to look
Tratar
at the
de pensar realmente quién está
sources
detrás del
and
financiamiento de
who
aquellos
is
estudios y cuáles son
financing
los
all of this
intereses
research, who's
y
behind it, what interests
simplemente
are
abrir
at
la
stake.
discusión de los datos
So I would just like to open up
al
this
mundo, a la sociedad civil.
debate
Después
regarding the
también
data
me
to
parecía
the
muy importante
world of civil
trabajando
societies.
en
And
una
finally, I think
organización
it's
que
very
mira los
important
impactos ambientales de
that
la
we're working in
extracción,
an
los impactos en
organization that
derechos humanos,
considers the
volver a poner sobre
environmental
la mesa
impacts. We look
que
at
todas las
the impact
decisiones
of
a lo
extraction
largo
on
de la
human
cadena de
rights,
valor
and
involucran
we
impactos
need to think
ambientales,
about
algunos
the impact of
muy graves, que no
decisions
hay
on the
decisiones inocuas
value
y que
change,
siempre
because
los
all
mejores residuos son
decisions
los que no se
have
generan, ¿no?
an
Como tratar
effect,
a volver,
and the
no
best
perder de
waste is the
vista
waste that is
todo
not
el eslabón
generated.
de
So
la
we
cadena de
mustn't lose
suministro
sight
y todos los
of
pasos en el
this
medio. Por eso nos parece
supply
muy
chain.
relevante y coincidimos
It's
con la
very
mirada
relevant,
crítica, con la
and
mirada
we need to
crítica,
look
con
at
la
this through a
jerarquía,
critical lens. We need to look at it
claro, para
holistically,
baterías
and we need
generó
to
Gaia
look
de
at it
una
through the
manera
lens
fluida.
of zero
Y acá
waste,
algunas reflexiones más
so
generales, ¿no?
as Gaia
Y
does,
antes de
and some
pensar siquiera en el
general
diseño de las
thoughts
baterías,
before
¿no?
thinking about the
Volver para
design of the
atrás, los
batteries.
sistemas de
Let's take a
producción,
step back.
consumo y desecho
What
de
about
naturaleza.
the
Empezar
systems
por
of production,
una mirada más
consumption,
holística
and
sobre las necesidades, ¿no? ¿Qué es lo que
disposal?
realmente, qué productos
So,
necesitamos?
what are the
¿Para
products that
qué
we
fines?
really need, and what do we need
Y
them
ahí
for?
poder distinguir entre
And then
usos
we need to
básicos
distinguish
necesarios y usos más
between
suntuosos,
basic,
que hay
necessary
una llamada a
uses
los
and
vehículos
those that aren't.
eléctricos, que
So,
son
for
lugares
example,
que pareciera ser
here I
ya de
would
extremo lujo,
call our
¿no?
attention
Entonces
to
es importante, antes de
e-vehicles
pensar en los productos,
that
tener una
we
mirada
could
sobre
question how
la naturaleza.
important they
Y
really
después,
are. So we
acá
have to
también lo
think
que
about the
resaltaban en
use
el
of each
estudio, como que
product.
todavía no
And
están
then
probadas, no
there
es
is
tan
another
claro el
issue,
impacto, porque algunas baterías
which is that we're
no
still
llegan al
not
fin de su vida útil.
clear on the
Acá
impact
ya
of
la
some
alarma se
batteries.
enciende sobre la falta de
And this
políticas
is like
integrales y de
an alarm
coordinación, con una mirada
because
de
it warns
prevención y
us
de
about
historia, ¿no?
comprehensive
Sobre
policies
cómo
and
pensar los distintos tipos de baterías,
coordinated
los
work,
materiales,
because we
los
have to
productos
think
que van a terminar
about
en un problema
these
inminente
different
que,
types of
como sabemos,
batteries and the
muchas veces
materials
en
and the
su lugar
products
terminan
that
pueden
are going
terminar en
to
residuos
cause
sanitarios
an
y
imminent
tratarlos y
problem
afectando a
in the
poblaciones en
global
situación
south,
de
because we're
vulnerabilidad, con
filling
toxicidad y otros
landfills.
problemas que
It's
se mostraron.
affecting
Después
vulnerable
también
populations
la
through
pregunta
toxic
quizás en estos
emissions.
espacios donde se
And
discuten los
these are all
minerales,
issues that
hablar de
we
qué
face.
se
So
trata,
the
lograr
other
una mayor
issue
movilidad
has to
de
do with
automóviles de aquí
a
para allá.
greater
O podemos
mobility
volver a pensar en
of
cómo hacemos
of
que las
cars
personas
or
se
automobiles?
acerquen a
Do we
los
have to
lugares que
think
necesitan
about
más
increasing
hacer su
this
necesidad,
mobility,
pensar
or can we think
en
about
salir
other
de
ways that
donde
people could move
individual,
around?
ya de
Maybe we
reducción,
can
tiene
stop
que
thinking about
en cómo
individual
hacer
mobility
menos
and
uso
change our
de la naturaleza en
perspective
general y cómo
so that
volver a
we're
opciones de movilidad
using natural
activa,
resources
colectiva,
less and that
común,
we're using
cooperativa.
joint
Después
forms of
las preguntas
transport.
que se hacen
And
sobre
then
eficiencia de recuperación de materiales,
Questions on
el reemplazo y
efficiency,
el
material
repropósito. Todo esto
recovery,
lleva a pensar, bueno, ¿qué significa esto para el
repurposing.
sur global, no?
We've
¿Qué
got
es
to
lo que va a
think what all
llegar a
this
las
means for
economías
the
del sur
global
global? ¿Qué
south.
productos, qué
What's going to get
residuos,
to
qué
those economies?
materiales?
What waste, what
¿Qué va a pasar
products,
con
what
los trabajadores, con
materials?
los
What's going to
ecosistemas, con las
happen with
comunidades que hoy
workers, with the
reciben
systems,
pero
with
no
the
participan de ese
communities that
consumo
are
y
recipients but
ese
don't
supuesto
participate
bienestar,
in
entre
this
comillas, que traen
consumption or
la transición
alleged
energética?
well-being
Y
of
acá,
energy
como dos puntos
transition?
finales para ya no
Just
pasarme
two
muy cortitos,
final things
el rol de
now,
la
not to
regulación
go over
en un
time. The
contexto
role
de
of
una tendencia a la
regulation in a context and a
desregulación de
trend
todo. Vemos que
towards
justamente la sociedad está yendo a
deregulation of
desregular
everything.
todo. ¿Cómo
Society
hacemos
is
para
tending to
la
deregulate
regulación, los
everything.
incentivos
How do
adecuados,
we
el rol de
regulate,
lo
provide
público sobre
appropriate
lo privado?
incentives, the
Y acá de
role of the
vuelta,
public over
responsabilidad
the
exclusiva del
private,
productor, el rol de la
extended
ciencia,
producer
la innovación.
responsibility, the role of
¿Cómo hacemos
science, of
realmente para
innovation?
que haya
How
información
do
pública
we go
ambiental
about it so
versus el
that
secreto
there's
industrial? Y la
public
último punto, ahí ya bien
environmental
cortito,
information
¿qué hacemos en un momento
over and
donde
above
no hay
industrial
una apuesta muy
secrecy?
fuerte a la
Now,
cooperación
what do we
multilateral?
do
¿Cuáles
when
son
there's not that
los
much
lugares, los
multilateral
espacios
cooperation?
donde
What are
estas
the
discusiones
spaces
deberían
in
llevarse
which
a cabo con
these
todas las
discussions
miradas
should
y
take
el sistema
place,
multilateral y colectivo en el centro,
listening
¿no?
to
Cada
all
uno está por su parte
opinions?
y necesitamos una
Uh,
mirada colectiva a
we
este problema.
need a
Ay, perdón, muchas
collective
gracias. Me pasé unos
vision of
segunditos,
this
perdón.
problem. I went
Muchas
over
gracias.
time, but just a couple of seconds. Thank
Gracias,
you.
Pia. Thank you. Now we have Raquel Dominguez, our next speaker. Go ahead, Raquel.
Hi.
Thank you.
Thank you so much for having me. For those of you I don't know, my name is Raquel Dominguez, and I work at a US-based organization called Earthworks. And Earthworks was founded to support communities, mostly in the US, on the front lines of oil, gas, and hard rock mineral extraction. Hard rock minerals is just a US specific term for stuff under the ground that is not oil, gas, or coal or uranium. So when I started at Earthworks, I was mostly working on bills to help reform the 1872 mining law. But I've been at Earthworks for 5 years now, which is absolutely wild. And now I'm working on circular economy policies. And it's been really interesting because I joined Earthworks with, I would say, a very shallow understanding of mining and of extraction in general. And as I've learned more with this job, I've started understanding that any just transition we have it's not going to be a simple one-to-one swap of anything. A lot of people, particularly in the US, really begin and end their understanding of transition with electric vehicles. And that's for a lot of different reasons that could fill up many, many books. But that is largely because of what Pia was speaking about, which is that we're a very car dependent society. We have 0.9 cars for every one person in this country, and swapping every internal combustion engine vehicle for an electric vehicle does not actually solve any of the underlying systems that began and are accelerating the climate crisis. Talking about extraction, talking about white supremacy, many, many interconnected things. So as I have worked more with GAIA and with FARN and many of the organizations that are attending this webinar, I've become more and more interested in these very, very big picture long-term solutions to these underlying systems of oppression that have caused the climate crisis and all of the other crises that are going on, particularly biodiversity. And so I really enjoyed this report because it wasn't just looking at recycling, which is something that I spend a lot of my time kind of pushing back on. Because again, especially in the US, you have a lot of people hearing I talk about circular economy and going, oh, so recycling and battery recycling. And it's very interesting to kind of disagree with them and say, yes, recycling, but only after a battery has been used multiple times. Because everybody I often say everybody wants a silver bullet. Everybody wants an easy solution to these very complicated, very scary, very overwhelming things. And everybody wants to just, build some recycling facilities and move on with life as we currently have it. And that's not really what I'm interested in exploring. So I really appreciated that this report talks about the whole life cycle approach. And as Pia mentioned, it could go even further, either in this report or in many others. Instead of just thinking about how a battery is designed, and it should be designed for circularity, it should be designed for disassembly, it should be designed for repair and manufacture and all of these things, we should be thinking about why do we need batteries, and who is determining what need is, and who is going to be using said batteries. As many of you probably know, the vast majority of projected demand for transition minerals like lithium, cobalt, graphite, all of that stuff is for EVs in the global north, which is, of course, not where many of these minerals are being extracted or processed. So, of course, very few of the consequences are happening in the places where these vehicles are being manufactured and used. And so I do think we need to think much bigger about this stuff. How did I use 4 minutes already? That is so funny. We do need to think big picture. And as things get worse and get scarier and we learn more about extraction and the consequences of it, we do need to think about totally redefining how we move around and how we produce waste and who's producing waste and where is that waste going. And I will stop there, but thank you very much.
Thank you, Raquel. Now we have a 10 minutes question and answer. I have 2 questions that you wrote in the chat. But first, I want to thank you all who is attending this webinar, because I read messages from Chile, Nigeria, US, Canada, Ukraine, Ecuador, Manila. So thank you everyone for being here. My first question is somebody wrote, Lynn, I think that maybe you can answer that. Wait. It's about recycling process, so let me get it. Okay, when you say 80% reuse or repurpose, it means the same battery used again? How many times can this happen? This is the first question, if you want to answer, and then I have another one.
Thanks, Janina. Yes, I did answer this one in writing, but happy to do it for everybody as well. Just like with cell phones over a period of time, the lithium-ion battery, you can't charge it to 100% anymore. There's a level of degradation that happens over the life of the battery, and so when it can only charge up to 80% anymore is when it's removed from a vehicle. It's no longer safe to operate a vehicle with that level of capacity remaining. And so at that point is when we need testing or assessment. This particular battery, with its level, with its history of use, with its maybe past adverse events, with more robust testing of its level of degradation and the capacity remaining and the overall state of health, what is its next best use? And typically under normal conditions, that type of battery can be used as energy storage when stacked together with other used batteries. EV batteries can be stacked together into, for example, a battery bank, serving as energy storage for wind or solar or other renewable energy or intermittent sources. That is something that can last 10 or more years, is what we've been understanding. And so there's a great, opportunity there for the increased need that we have for energy storage, to conserve and to use the many, for those of us who work on mining, right, and the human rights impacts and the energy emissions related to mining, to be able to extend the life of those embedded carbon emissions in those minerals and to have that be conserved and used for longer in the plastics and all of the other material in the battery, to have it continue to live on for another 10 years is huge. And we have that opportunity to make that case, but there's a lot of other, fire and other issues related to that. So yes, it really depends on the battery. How many times? Is it one life? Is it many lives? But at least one life, yes, can be viable depending on its history. Maybe to jump to the next question from Jasmine. Thank you, Jasmine, for your question. This is a great one. Do all different battery chemistries, whether it's NMC or LFP, can they, do we know enough about which pathways are available, right, to recycle those batteries? And then what are the levels of energy intensity and air and water toxicity and other impacts? We don't know. We want to know. We need to do more. We need to have a stronger technical understanding of that. And so we continue to look at that as GAIA. But most of what I presented is primarily for battery types that are cobalt and nickel rich. And absolutely then for, yes, sodium ion batteries as well is on the horizon, and understanding the recycling processes for those as well. We don't have a strong enough understanding yet. It's on our wish list of to work with scientists and technical analysts to better understand the ins and outs of that. And then for the next question that I see here from Nicole, when I say that it's cheaper to mine new lithium than to recycle it, how often? I mean, this is something that's been true for the past few years, and it really depends on market conditions, and I am no market analyst. So I cannot predict the future, and we are in very turbulent times right now where many other geopolitical considerations are taking over, right? So I don't know. I can only say that for now, for what we've been monitoring for the past few years, this is what tends to be true. Or that the graphite, right? For instance, okay, you can in theory recover graphite, but it's of such low quality, right? That it's not really usable. It's not battery grade material. So that's as much as I can answer that question at the moment. From Jean, thank you. Trying to read this question. I think, yes, I tried to understand. It was repetitive of another question, I believe, of what are the recycling processes for LFP or other battery types. Is anyone looking? Yes, go ahead.
Yeah, no, I'm going to say that you can write your mail in the chat that was in the last slide. So I have a question for Pia. I would like to know her opinion about what key issues or what things should we discuss in the South or with decision makers.
Creo que es una discusión sumamente
I think
compleja,
it's a
porque
very
la realidad es
complex
que
discussion
decisiones estas no se
because, in
están tomando
fact,
en el
these
sur global.
decisions are
La
not being
transición
made in the
energética se
global
está llevando
South.
a cabo en el
Energy
norte global.
transition is taking
Economías y
place
sociedades
in
como
the
Argentina están
north, and
apostando por
economies and
ampliar la frontera
societies like the
hidrocarburífera. O sea, no
Argentine
estamos
one
haciendo
are
transición
trying
energética acá.
to
Estamos
extend the
proveyendo los
hydrocarbon
minerales
borders. We are
a
providing
costos
minerals
ecológicos sin derechos
at
humanos, y después estamos
paying
viendo
high
cuáles van a
prices
ser
in
las
the field
decisiones de
of
tecnología
human
que
rights and
deciden
the
las
environment,
empresas en
then
algún lugar
we've got to
de
look at
países de
the
China o de
decisions made
Norteamérica
by
o de
the
Europa,
companies in
y con eso
the
ver qué va a
US, in
pasar
Europe, and
con
in China, and
nuestra
see what's going
posible
to
transición
happen
y
with
con
our
lo que derive de
potential
eso, ¿no?
transition
Así
or
que
whatever stems
las
from that.
discusiones sobre
I
los
believe
nuevos
that the
significados y
discussions
el
on the
reuso de las
new
baterías para
meanings and
energías
the
renovables
reuse of batteries
tenemos
for renewable
muchísimo que
energy,
discutir en
well, we
ese
still
sentido,
have a
pero
lot to
estamos
discuss in
llegando
the
a,
South.
ni siquiera
But
podemos tener todas las aristas del debate, porque
we
los secretos industriales, las decisiones
need
de qué
to look
batería
into the whole of the
para qué
debate.
uso depende de
I
cuestiones
mean, what
totalmente
battery
alejadas
for
de
what
donde
use?
estamos, ¿no?
Well,
Vamos por
that's
una o
far
por la
from where
otra,
we are
dependen de decisiones también de
nowadays.
automotrices
It depends
privadas en
on
función de qué
the
acceso a qué
automotive company
minerales tienen y
decisions,
cuáles son
on
sus
what minerals
discusiones
they have
industriales. Está
access
totalmente
to,
alejado del
what
sur,
discussions
de
they're
la
holding.
preocupación
That's
ambiental que
far from the
traemos como
South and
organizaciones
from
ambientales, ¿no?
our
Creo que es para
environmental
seguir
concern
debatiendo
as
en un espacio
environmental
así, pero es
organizations.
necesario, sin
I
duda.
think we have to debate this further. Thank you.
Thank you, Pia. Now we have just 5 minutes. I know that there are a lot of questions now in the chat. I invite you to write to Lynn's mail or to contact us in the channels where Gaia is. You know that we have the 2 documents in Spanish and in English in the Gaia's website. You can download it there and read it. Some of the things that Lynn mentioned are there, well written. So I invite you to download the document. Thank you, Lynn. This is in the chat. There is the Lynn's mail, Lynn and no burn for more information. So I think that we are getting to the end. I don't know if Lynn, you want to say something, or Raquel.
I just want to say thank you. I love all the questions. Wish we had more time. Please do feel free to reach out. Thank you so much. Thank you to
Thank you.
Pia and Raquel as well.
Thank you, Pia. Thank you, Raquel.
And the Yanina and the interpreters too for making this webinar possible. Thank
Yes.
you.
Thank you, everyone. Bye-bye.